Today we will be going over section 2.2 of your geometry book. We will be talking about statements and their truth values and tools to help us determine the truth values of statements. A statement is simply a sentence that is either true or false. All statements have a truth value of either true or false. Statements cannot be sometimes true or sometimes false. If there is ever a time that a statement is false, that statement's truth value is false. Statements are often represented with a letter such as P or Q. For example, this statement, P, says a rectangle is a quadrilateral. Since a rectangle is always a quadrilateral, the truth value of that statement is true. The negation of the statement has the opposite meaning, usually with the word not, and has the opposite truth value. Not P, as we can see with this symbol right here, would be a rectangle is not a quadrilateral. Since rectangles are always quadrilaterals, this truth value is false. When we put two or more statements together using either the word and or the word or, we call that a compound statement. One type of compound statement using the word and is called a conjunction. A conjunction is true only when all the statements that form it are true. For example, if I have a statement P, a rectangle is a quadrilateral, a statement Q, a rectangle is convex. The conjunction of P and Q is a rectangle is a quadrilateral and a rectangle is convex. We can use the word and to show that this is a conjunction, P and Q, or we can use this up caret symbol, which also means and. Since both of these statements are true, our entire conjunction is true. This is very, very important. If any of the statements that make up a conjunction are false, the entire conjunction is false. A conjunction is only true if all the statements that make it up are true. Another type of compound statement is called a disjunction. A disjunction is a statement that joins is a compound statement that joins two or more statements with the word or. We can show that with the word or between our statements or a down caret symbol that also means or. This is very, very important. A disjunction is only false if all of the statements are false. Therefore, if some of the statements are true, a disjunction is still true. A tool that helps us determine the truth value of statements is called a Venn diagram. We have different kinds of Venn diagrams: all, some, or none. This diagram includes two all statements and a some statement. In this Venn diagram, we have one circle that represents assumptions. This circle A is how we feel when we only make assumptions about things. Dope. This circle represents information. When we only have information but we do nothing with it, that's what happens with B. We think about it, but we haven't come to any conclusions yet. However, when we take information and we make an assumption about that, or a conclusion, that's this overlap right here, the sum part of the Venn diagram. We call that in science a hypothesis. In math, we call that a conjecture. Venn diagrams can help us figure out the truth values of conjunctions or disjunctions. This is an example of our conjunction Venn diagram. We had our two statements, a rectangle is a quadrilateral, a rectangle is convex. So here, this circle, this blue circle, represents the rectangle being a quadrilateral. This red circle represents the rectangle being convex. When those two combine, we get a rectangle is a quadrilateral and a rectangle is convex. This statement is true, so everything in the blue is true. This statement is true, so everything in the red is true. Therefore, the overlap is true also. The only example that would be false would be a concave triangle. If I take that example and replace the word rectangle with that, a concave triangle is a quadrilateral and a concave triangle is convex. That's false. If I choose an example that's here, something that is a quadrilateral but is not convex, a concave quadrilateral, I could say a concave quadrilateral is a quadrilateral. That's true. A concave quadrilateral is convex. That's false. So that statement is false. If I choose an example in the red area, and I say an example that is convex but not a quadrilateral, for example, a convex pentagon. If I say a convex pentagon is a quadrilateral, that's false. A convex pentagon is convex. That's true. The whole statement is false. The only example is one that would lie in the overlap that is true. For a disjunction, anything that lies in any of this blue area is true. Using the same examples again, if I were to say in this overlap, a rectangle is a quadrilateral or a rectangle is convex. Since both of those are true, that is a true statement. If I were to take an example over here, something that is a quadrilateral but is not convex, like a concave quadrilateral is a quadrilateral, or a concave quadrilateral is convex. Even though one of those parts is false, one is true, so that statement is true. If I choose something over here, something that is convex but not a quadrilateral, like a convex pentagon is a quadrilateral, false. A convex pentagon is convex, true. Put those together with an or, since one of those statements is true, the whole thing is true. The only example that would make that false is a concave triangle. For this activity, I would like you to make a Venn diagram. Make it a sum Venn diagram with two categories, like the previous one. This one had quadrilaterals, this one had convex, and they overlap in the middle. For the second part, I want you to write examples in your different parts of your Venn diagram and shade your Venn diagram so that it's a conjunction. For the third part, I want you to take that same Venn diagram with your examples, but now shade it so that it is a disjunction Venn diagram. The last tool we're going to talk about is a truth table. A truth table helps us organize all the possible truth values for a statement or a group of statements. For example, here I have a truth table for a negation. I have statement P. Statement P can be either true or false. Not P, if statement P is true, then statement not P is false. And if statement P is false, then statement not P is true. These truth tables show us all the possible truth values for a conjunction or a disjunction. If I have a conjunction made of statements P and Q, and both of P and Q are true, then my conjunction is true. But if one or both of them are false, as in these examples, then my conjunction is false. Or a disjunction, if one or both of my statements are true, then my disjunction is true. Only if they are both false is the disjunction false. I'm going to explain to you how to make a truth table. If I'm going to make a truth table for P and not Q, I need to make my headings first. I always start with the two statements or more statements that make up my truth table. Since I have P and Q here, I'm going to put those in my headings. But I notice that I need not Q, so I'm going to put that in my heading. And then finally, I will want the truth value of it all put together, P and not Q. The next step, I list all the possible combinations for truth values of P and Q. P can be true and Q can be true. P can be true and Q can be false. P can be false and Q can be true, or they can both be false. You can put these in any order as long as you have all four combinations. Next, I look at the truth values of not Q. Since they depend on the truth values of Q, I'll have to look there each time. If Q is true, then not Q is false. If Q is false, not Q is true. If Q is true, not Q is false. And if Q is false, not Q is true. Now, I'm going to put P and not Q together. So I will be using this column and this column to help me determine the truth value of that column. In the first row, P is true and Q is false. Not Q is false. Since one of those is false, my conjunction must be false. In the second row, P is true and not Q is true. Since both of them are true, my conjunction is true. In this row, P is false, not Q is false. Since one or more of them are false, the whole thing is false. And finally, in this row, P is false, not Q is true. Since one of them is false, the whole thing is false. We will work the other examples together in class.